What's up? This is your all-time favorite teenage teacher. Today's video is going to touch on geometric sequence series. By that I mean the different types of geometric series and some useful examples. Yes. So important formulas for. Okay, before I tell you the formulas, let me briefly say that there are two types of geometric sequence series. So the first one is the finite geometric series, and the second one is the infinite. So we are going to be looking at the finite geometric sequence first. Yeah, because it seems right to do so. So we have two formulas actually. They can be used interchangeably because they're the same. It's just that which one to use at what time. So here is the rule. So if you want if you want your denominator to be positive, use let me say r is, for example, positive. If it's positive and greater than 1, do not use this formula, because let me say r is equals to 2 and you put 1 minus 2, that becomes negative, so it makes your work harder. So instead use this. Let me say your r is negative, and if you use this, it will make it more negative. For example, minus 2, 1 minus 1, that's minus 3. But if you put it here, it will become positive 3. So that's how you differentiate between this formula. Otherwise they're the same. So let's do our first example. As usual, draw the first line. I like drawing lines for maths. Okay, so let us consider the geometric sequence found above. Un is equal to 24 divided by 5 times bracket minus 5 over 2 to the power n. So it helps to write the equation first. It will help you focus more. And so we're supposed to find the sum of the first 8 terms, and in order to do that, first we need to know what's u1, and our r is already given to us. It's minus 5 over 2 right here. This is our r. So in order to find u1, we just need to add, make n 1. So that gives us minus 12. So simple as that. And we're supposed to find the first sum of SA. We're supposed to find SA. So u1 times 1 minus rn divided by 1 minus r. Remember what I told you? The denominator, if the denominator is positive, it will make your calculation easier. So minus 12 times 1 minus 5 over 2 to the power 8, actually, because we are solving for 8. So divided by 1 minus 5 over 2. So if you simplify this, you will get 5228.16, or if you want to put it in 3 significant figures, 5.23 times 10 to the power 3. So you can do this on your calculator and find the answer. Let's move on to infinite geometric sequence. So what's the equation for the infinite geometric sequence? As given, as you can see right here, is this denotes infinite. So u1 divided by 1 minus r. But there's a condition for this formula right here. R must be put in a modulus equation. So to simply describe what modulus is, so if you put a negative number, let me say minus -6, when it comes out it's 6, and if you put a positive number, when it comes out it's still positive. So, and the second condition is that it has to be less than 1. So it's, let me say, even if I put something like -5, then when it comes out it's 5, but 5 is not, 1 is not greater than 5, or 5 is not less than 1. So it has to be between 0 and 1, but it does not include 0 or 1. So let's do our second example together. Okay, so let us consider a geometric sequence with a common ratio between -1 and 1. So un is given to us as 243 times 1/3 to the power n. Find the sum of the first 3 terms. So as I said, write the question first here. So first we need to find u1. The usual u1 should be first the power 1. This is 81 on your calculator. So to find the sum of the first 3 terms, just use this 1 minus Rn divided by 1 minus R. So that will be 81 times 1 minus 1/3n, no, 1 to the power 3 divided by 1 minus 1/3. So if you calculate this on your calculator, what you will get is 117. Let me know in the comment section, or you can simplify it if you want. This is 2/3, this is 1/27. Yeah, you can do it like that, or you can use a calculator. Okay, for our last example, or for the third example, in fact, if you have noticed this, if you have watched all of my videos, this section of this geometric series has less examples, because those ones have like 6 examples. Yeah, so that's an improvement, right? So for geometric sequence, the sum of the first 3 terms is 91 divided by 9. So in the finite sum of all the terms is 21 divided by 2. So find the common ratio. So in this question we have to use both finite geometric series and infinite geometric series. So let's start with the finite one. So we know is the sum of the first 3 terms. So we know S3 is 91/9 automatically, and the sum of infinite sum of the term is given to us as 21 divided by 2. So find the common ratio in the first term. So let's start with the finite. So S3 is u1 1 minus R n divided by 1 minus R. Okay, so S3 is 91/9, yeah. So u1, we don't know u1, 1 minus, but we know n, which is 3, same as here, divided by 1 minus R. And for the infinite one, we know already it's 21 divided by 2, and the formula is u1/1 minus R. We know that as well. So we're supposed to find u1 and R from these 2 equations, this one and this one. So from the second equation we can deduce that u1 is equals to 21 times 1 minus R divided by 2. So we can simply substitute this inside this. So that will be 9 t1 divided by 9 is equals to 21 times 1 minus r by 2 times 1 minus r3 to the power 3 divided by 1 minus r. So let's simplify 1 minus r by 1 minus r. So that would be 91 over 9 is equals to 21 times 1 minus r to the power 3 divided by 2. So how can we solve this? 91 divided by 9 on my calculator is 10.1, and 21 divided by 2 is 10.5. So that's 20.5 minus 10.5 r to the power 3. So 10.1 minus 10.5, that is minus 0.4 is equals to minus 10.5 r the cube. So if I divide this by my minus 10.5, I'll get r3 to be 0.038095. So a cube root of that will be 0.33, which is equal to 1 over 3 technically. So to find u1, since I have no space, let's go up. So u1 is equals to 21 times 1 minus 1 over 3 divided by 2. So that is 7. So u1 is 7. So one last tip, formula Sn is equals to u1 times n minus r to the power n divided by 1 minus r, and S infinity or infinite sum of geometric series u1 divided by 1 minus r. You can notice that Sn is equals to this basically what we did right here. So to find u1 in r, sometimes they will give you the Sn, the sum of the finite geometric sequence, and also the infinite. So you have to do substitution in order to find these two. So that's it for this video. Thank you for keeping up with me, and yeah, since this is the last video for the sequences in the series playlist, I'll be uploading my PowerPoints as well together with the video. So see you later.